Okay, so over here we've got another example of multiple regression, and we're busy analyzing the table. So over here they say that the dependent variable is anxiety, but I must say over here we're going to strive to answer or evaluate each of the research questions that multiple regression can be used to answer. So as we can see over here, the first question that they say multiple regression can be used to answer would concern how well a set of independent variables is able to predict a particular dependent variable. Now in terms of that, do you remember we said that, excuse me, I beg your pardon. Okay, the R square can be used to determine the amount or the percentage of variance in the dependent variable that is predicted by the independent variables that are involved. So we said R square is used, okay? So we will get back to that now. So in this table, okay, multiple regression, like we said, anxiety is the dependent variable. So now we never look at this row that says constant. We don't really, I wouldn't say we never look at the row because the R square is in that row. But in terms of the beta values, we don't look because there isn't a beta value, as we can see. So I presume in this study, because I didn't get a description, but all of these variables that are mentioned over here are believed to contribute towards anxiety. So we want to see, out of all of these variables that are said to contribute towards anxiety, which of them are found to statistically and significantly contribute towards anxiety. So which of them have a statistical significance as predictors of anxiety. Okay, so if we go through the p-values, because remember we first want to see the variables that have statistical significance, and we will only take those into further analysis. So as we can see under the p-values, okay, here we've got practical statistical significance. Now, how do we know it's statistically significant? If a variable's p-value is equal to 0.05 or less. Okay, and like we've said, if the p-value is between 0.05, if it's equal to 0.05 but not equal to 0.01, if it's between that, then we've got 95% confidence in that variable as a predictor, whereas if a variable has got 0.01 as a p-value or less, we have 99% confidence in that variable as a predictor of the dependent variable. So over here, this is less than 0.01, so it meets the bare minimum of 0.01. Therefore, overload, we have 99% confidence in overload as a predictor of anxiety. Okay, so moving down the p-values, what is the next variable that has a significant p-value? And we can see in this table p-values, let's double check. But the stars, the asterisks, the static keys are next to the p-values. But we know that the p-values are significant because I've discussed it now. Okay. So now in this case, we can see this p-value is also significant. Okay, which variable does that refer to? Colleague support. So in other words, these statistics are suggesting that colleague support is also a statistically significant predictor of anxiety. Okay, so what is the next p-value that we find that is statistically significant? Over there, and this refers to role clarity. So role clarity is a significant predictor of anxiety according to these statistics. There's another p-value that it indicates significance, and this refers to home pressure. So therefore, the statistics are suggesting that home pressure is a predictor, a significant predictor of anxiety. So now what we do next is, if we want to see the independent variable that has the highest highest unique effect towards anxiety, we look at the beta value. So where's the beta value column? It's over there. Okay, under standardized coefficients. So we'll highlight the beta value of overload, highlight the beta value of colleague support, role clarity, and over here the negative signs in front of the values. I believe that the same principle applies as would in correlation. So a negative relationship exists between anxiety and colleague support. So therefore, as colleague support decreases, anxiety will increase. Okay. Now getting back to the beta values, home pressure we can see has the highest beta value, but it's not really that different from the second highest, which is overload. But home pressure does have the highest beta value, so therefore home pressure has the most unique effect towards anxiety in terms of the first set of variables. So now you'll see all of the variables are the same up until home support, but then in the second stage, as indicated over here by number 2, two additional variables were entered into the multiple regression, and these concerned negative work-home interaction and negative home-work interaction. So over here we're talking about negative interaction from the work towards the home, and over here we're talking about negative interaction that is brought from home back to work. So okay, now in the second set, so now the independent variables, in the second step, negative and negative WHI and negative HWI, as we said, have been entered. So now we want to see which variables have statistical significance. Okay, so over here the first value we see that has a statistical significance. Let me zoom in a bit. Okay, in the second step, what's the first variable that has statistical significance? Okay, there it is, 0.05, and that refers to overload. Okay, then the next, colleague support. Okay, the next value, also role clarity, and remember, we're marking these as statistically significant because they have p-values that are equal to or less than 0.05, but I believe in this case this author also used a star or an asterisk to mark the variables that are statistically significant. Okay, and then negative work-home interaction we see is statistically significant. Okay, and then negative home-work interaction is also statistically significant. So over here we want to see in the second step, out of all of the variables that were involved, which of those that are statistically significant have the highest unique effect. And where do we look again? We look at the beta value. So here is the beta column. So we'll go down. Okay. So let's mark the beta value of each of the statistically significant variables. Okay. Okay. So now out of all of these statistically significant variables in the second step, which has the highest beta value? Oh, we see negative work-home interaction and negative homework interaction have the highest unique effect. And they're both equal. So each of them have an equal degree of unique effect towards anxiety. And they have, like we said, they have the highest unique effect. So in the second model, we want to see the degree or the proportion. I'm trying to think, the proportion of variance in anxiety that the second model can explain. Now remember, the model refers to the combination of independent variables. So after negative work-home interaction and homework interaction were entered into the equation, how much of anxiety or a variation in anxiety can be explained by the new model. And remember to look at that. We look at the R square value. Okay, so we'll get to that now. See, we didn't look at it in the first model. We'll go there now. Okay, so now in the second model, since we just touched on that model, I'll discuss that one first. So in the second model, because the R square value equals 0.23, if we times that value by 100, we get 23%. So therefore, the second model can explain or predict 23% of the variation in anxiety. And now the first model, before negative homework interaction and negative work-home interaction were entered, the model could explain 18% of the variation in anxiety. Okay, and then another thing over here, I don't know about if they're going to ask this, but this, let me just double check what it refers to, this value over here. Quickly scanning through my book. Okay, but I believe they call that change R squared. R squared change, yes, okay. So this change sign in front of R squared, that is called R squared change, and that in this, it basically indicates the additional percentage of variance that can be explained by the new model. So therefore, since this is 0.05, since negative work-home interaction and negative homework interaction were entered into the model, an additional 5% of the variance in what you call it, excuse me, anxiety can be explained or predicted. Okay, and then for interest's sake, yeah, like I said over here, I marked it 18%. Okay, so let's go and don't yeah, worry, don't get nervous when you look at all these fancy numbers and all of that. So now, entry of job and home characteristics at the first step of the regression analysis produced a statistically, I think they were supposed to say significant model, accounting for approximately 18% of the variance. So now, where did we get that 18% again? We went to the R square value, because we said most R square value indicates the percentage of variation in the dependent variable that can be explained or predicted by the model. In this case, they said accounted for. Okay. So now, since overload, colleague support, and lack of role clarity, as well as home pressure, were found to have were found to be statistically significant. Here they are mentioned that it is mentioned that they are seen to be predictors of anxiety. Because we look up there, okay, like we've marked, overload, colleague supports, role clarity, and home pressure were marked as statistically significant. So therefore, here the author says that they seem to be predictors of anxiety. Okay, I'll just leave it there for a few seconds so that you can read it if you want to. Okay, so now going to the second step, okay, like we saw, negative work-home interaction and negative homework interaction were entered, and then an additional 5% of the variance in the dependent variable of anxiety, as indicated by the R-squared change, because I remember in statistics we learned that symbol represents or stands for change. Okay, so the R-squared change in the second step equals 0.05. Therefore, the second model has added, well, it can explain an additional 5% of the variance in the dependent variable, which is anxiety. So let's see how they phrase that. When negative work-home interaction and negative homework interaction were entered in the second step of the regression analysis, a statistically significant model was produced. Okay, because we can see, then let's check the p-value. Okay, also it's statistically significant. Okay, so now a statistically significant model was produced, which explained 23% of the total variance. Remember, where do we get that? We look at the R-square value. Okay, there it is. Okay, it seems that both negative work-home interaction and negative homework interaction are significant predictors of anxiety. So therefore, after we've mentioned the relationship or the significant predictors towards the dependent variable out of the first model, then we describe out of those that were added in the second model, which of those are also significant predictors of anxiety. And I believe that if none of them are, then we'd say neither negative work-home interaction or negative homework interaction were suggested to be significant predictors of anxiety. So there you go. That's another example of multiple regression analysis. I trust that it's helped.